Compute engine. A compute engine is a physical server that runs inside the GCP environment with a number of different configurations. It's a customized virtual machine running on Google Cloud. It consists of virtual CPU, memory, disk storage, and IP address. So there are two types of machines, predefined machines and a custom machine. Both predefined machine and custom machine allow you to pick your own CPU and memory for your work. So there are four different flavors of predefined machine types. Standard machine type are suited for the tasks that have balance of CPU and memory need. For example, your websites, your databases, or if you do not know which one to pick, you should pick standard machine type or a general purpose machine type. But if you have a memory intensive work like large inbound in-memory databases or in-memory analytics, you should use memory optimized machine type. Compute optimized machine type are used for high performance computing, gaming, electronic design automation, and single-threaded applications. Shared core machine types provide one virtual CPU that is allowed to run for a portion of time. Shared core machine types are F1 micro and G1 small. So F1 micro machine types offer busting capabilities also that allow instances to use additional physical CPU for a shorter period of time. It happens automatically when your instance requires more physical CPU than you originally allocated. Now, custom machine types are ideal for the scenarios where you have workload that are not fit for the predefined machine types. As we know that it costs slightly more to use a custom machine type than an equivalent predefined machine type. Each of these machine types support a maximum of 128 persistent disk with a total persistent disk size of 64 terabyte. Now this is a quota. We don't have to remember the quotas for every single product in Google Cloud, but there are certain quotas which you should remember. Now questions may not be directly asked about how many persistent disks you can have, but the question might be in a form that you should remember the quotas for certain products of Google Cloud. So you should remember that each machine type supports a maximum of 128 persistent disk and a total persistent disk size of 64 terabytes. Let's discuss some characteristics of virtual machine. Virtual machine does the live migration or a maintenance without interruption, which means you can move the machine and you can do the migration or you can do the maintenance of an application without stopping your applications. It also gives the right size recommendation, which means that it will suggest that you are using the right size of the machine. If you're not using the right size and if you need a smaller size, it will do the recommendation and you can take its recommendation and save some cost. You also can do the containers deployment on the VM. You pay for what you use. Again, you save the money by stopping the virtual machine if you're not using it. You can also get discounts. There are two types of discounts: sustained discount, which means that it automatically gives you a discount for running the virtual machine for a particular portion of the month. Or you have a committed discount where you already committed upfront, you commit that how much you have to use and take the advantage of the discount. Preemptible instances are short-lived instances where you can save 80%, and they are very good for a bad job or any fault-tolerant workloads. Now look into the virtual machine lifecycle. Now when you define all the properties of an instance and click create, the resources like CPU, memory, disk are all being reserved for an instance, and it is called as a provisioning stage. Next, the instance moves to a staging state where the resources have been acquired and the instance is prepared for launch. In this state, compute engine is adding IP addresses, booting up the system image, booting up the system by itself. So once that all is done, it moves to a running state. It will go through pre-configured startup script and enable SSH or RDP. While the instance is running, you can do the live migration of your VM to another host in the same zone, or you can move your VM to a different zone, take the snapshot of a virtual machine persistent disk, export the system image, and that's how you can move to a different zone. Sole tenant nodes. Sole tenant nodes physically isolate workload. So if you have a workload that requires physical isolation from other workloads or a virtual machine in order to keep the compliance requirement, you should use sole tenant nodes. It's a physical compute engine server that is dedicated to host a virtual machine instance only for your specific project. For example, if you have a payment processing workload that needs to be isolated to meet the compliance requirement, you should use a sole tenant node. Now let's talk about images. When creating a virtual machine, you can choose the boot disk image. This image consists of any bootloader, operating system, file system structure, any pre-configured software, or any other configuration or customization. There are two types of images, public image and custom image. Public image provides and maintained by Google, open source, or any third party. And custom image is owned by the user. Then there are premium images also. Now let's discuss much more detail on custom images. A custom image is a boot disk image that you own and control. You can create an image from the boot disk of existing compute engine instances, then create a new boot disk using that image and a new instance using that boot disk. And you can copy the image from one image to another image by using a G-Cloud tool or an API. Shielded VM. Shielded VM offers verifiable integrity to ensure that instances haven't been compromised by boot or a kernel level malware. You can achieve it by using secure boot or VTPM enabled or by integrity monitoring. In order to have the shielded VM feature, you have to select the shielded image while creating the virtual machine. So now next we will discuss disks. So after you have picked up your operating system, next you have to pick up the disk. Every VM comes with a single root persistent disk that contains the boot image. The disk is attached to a VM through the network interface. It is not physically attached to a machine. This separation of a disk and a compute engine allows this to survive even if the VM terminates. So you can also perform snapshots of these disks, which are incremental backups. Now you can dynamically resize them while they are running and attach to a VM. You can also attach a disk in a read-only mode to multiple VMs to share the static data between multiple instances. By default, Compute Engine encrypts all data at rest. This is extremely important exam that you should know. GCP handles and manages this encryption for you without any additional action on your part. But if still you want to control and manage this encryption, you have a customer managed encryption key and customer supplied encryption key that we will discuss later. So you have standard persistent disks that are backed up by standard HDD. You have balanced persistent disks which are backed up by SSD, and they are alternative to SSD persistent disk that balances performance and cost. And you have SSD persistent disks which are backed up by solid state disks. Local SSD are physically attached to a virtual machine. They're ephemerals. They can survive a reset, but not a VM stop or terminates. So you can attach up to 8 SSD disks with 375 GB each, resulting 3 TB of the total storage space. More IO apps, lower latency and higher throughput than persistent disk, which is very, very important that you should know that local SSD is much faster. They have low latency, higher throughput than persistent disk because they are actually physically attached to a VM. They cannot be reattached to a different VM for obvious reason. Let's look into compute engine actions. So we have covered 3 compute engine actions which are extremely important for the exam purposes. The first one is the metadata and the scripts. Every VM instance stores metadata on a metadata server. You can query this metadata about instance hostname, instance ID, startup and shutdown scripts. It's very important and useful in the combination with startup and shutdown scripts because you can use the metadata server to get the unique information using your script about an instance without additional authorization. For example, you can write a startup script that gets the metadata key value pair for an instance external IP address and use that in a new script to set up a new database. Now, storing and retrieving of an instance metadata is a very common compute engine action. Another one is to move to a new zone. You can move your VM to a new zone in the same region by using a gcloud compute instance move command. Or you can move it to a different region by making a snapshot, creating a new disk, creating a new VM attached to a new persistent disk, and assign a static IP address. Another example is, or another action is resizing persistent disk. You can resize the persistent disk while it is attached to a running VM for your I/O performance. So far, we have covered all the concepts of compute engine. And now you are ready to either go for the exam questions or you can do your work in a professional environment. You have covered all the concepts, and in my another video I would show you how to do the lab, and I will show you how to actually create the instance, use different options that will help you in actually practically working in your professional environment. Now, from the exam purposes, I have given 3 questions for your practice and give the explanation of each question, how to find the right answer of that question. So let's look into that. So let's look into the first question. You have created several preemptible Linux virtual machine instances using Google Cloud Compute Engine. You want to properly shut down your application before the virtual machines are preempted. So if you read the question properly, you know that it's about preemptible machine. Preemptible machine has a lifespan of 24 hours. So the question is that how you properly shut down your applications which are running on a preemptible machine before the machines are preempted. We have just gone through the concept of metadata and startup and shutdown scripts. So without any delay, you can always see the answer C is the appropriate one. It says create a shutdown script, use it as a value for new metadata entry with the key shutdown script in the cloud platform console when you create a new virtual machine instance. So answer C looks to be an appropriate answer. I have a link here that you can always go and look into it, and that's how it should be. So let's look into the next question. This question is based on how to move the VM to a different zone and how to create the boot disk and boot image. So let's look into this one. You want to make a copy of production Linux virtual machine in the US Central region. You want to manage and replace the copy easily if there are changes on the production virtual machine. You will deploy the copy as a new instance in a different project in the US East region. What steps you must take? We have just covered that how to move the instance in a different region, and looking into that, understanding that concept, so you know that answer D is the right one, where you create a snapshot of the root disk, create an image file in the Google Cloud Storage from the snapshot, and create a new virtual machine instance in the US East region using the image the file root disk. So answer D is the appropriate one. I have given the links that will explain in more detail and the explanations that will exactly you would know how to do it. First, you have to create the snapshot, and then you will use that snapshot to create the image, and then that image you create the different virtual machine instance. So that's the explanation, and answer D is the right answer. In this question, a production database virtual machine on Google Compute Engine has an exe4 formatted persistent disk for data files. The database is about to run out of storage space. So how can you remediate the problem with the least amount of downtime? In this question, you know that you have to resize the disk. And to do that, you do not have to shut down. the machine, you do not have to use fdisk command, and you do not have to use formatting or mounting. So all the options may not look correct. So option A is the right option, where you can, from the console, you can increase the size of the persistent disk and use resize to fs command in Linux. So I have given you the link, which will give you in more detail how it will work, and it will explain you in more detail how that command and how you can increase the size. This ends up our session for Compute Engine. Compute Engine is extremely important from the exam perspective. It's a very critical for your professional environment working. I have covered all the concepts that are required for Compute Engine, and hope you like it. I have given 3 questions where I have given the explanation of each question. For more videos, you can always come back and look into my channel. I will be adding up more videos on different topics. And if you have any specific topic that you would like me to cover, please let me know. And please don't forget to like and subscribe my channel. Thank you.